Hello, welcome to Governor Mifflin's Coding Club. This video is a supplementary to the lesson 1 of our coding club, basic LED circuits. Want to get your kit number 1, and from kit number 1 you'll have your SparkFun electronics board, the Arduino Uno or the red board, circuit board all wired up. You also have the basic lesson sheet to follow along during class. Now your instructor will go through the basics of circuitry and understanding LEDs, so you want to read through basics of programming before we get started. Now we've already wired the board up, so you won't have to do any wiring as far as hardware goes, but we are going to do the software in this video. So we get this out of the way. And what I'm going to do is I'm going to plug this up and we'll get started programming. The basic resistor circuit is listed here, and it's a resistor, an LED, and a battery, and that just lights up the LED. Now what we're doing with the controller is we are adjusting the control using the Arduino, and we'll show you how to start programming that right now. On your computer you want to pull up your Arduino IDE. Now what you see in the Arduino IDE programming platform is the top section here is basically your comment section. It's also where you would declare your variables. In this Blink program there are no variables, so it's pretty much just the comments on here. So all this is commented out. You can tell they're comments by the / on the before and after. Also a double / indicates a comment. So anything behind that the computer doesn't read. But if you have void setup here, the computer does read that. And also pin modes, the computer does read those things. So all the commented sections here, computer doesn't even notice. Now what you'll notice here is in the blink mode, in the void setup, this is where we're going to declare the pins of the program. Now the pins, you can see on the board itself, the pins are these pinholes that are numbered 1 through 13, and on this side there's your power, your ground, 3 volt, 5 volt, and also your analog pins on the bottom. So actually we're declaring the pins in the void setup section. In the void loop section is where we're going to write our program, which goes over, it continues to run over and over and over again. So those are the 3 sections. So again, your variable section at the top, void setup section is where you're going to declare your pins for the program, and the void loop is where we're going to write our program that's going to be running over and over again. Okay, let's start off with a new sketch, and we'll get started here. So let me get this new one set up. And we'll get rid of this guy. There we go. So when you declare a new setup, what you're going to see is basically the void setup and the void loop already put in. We're going to give us some space here. Now in our program itself, we are going to control 4 LEDs. And you notice the under the blink program it blinks number 13, and the blue LED is actually hooked to pin number 13. The green one be pin number 12, the yellow one be pin number 11, and the red one's going to be pin number 10. So we're going to declare our constants here. So there's 2 ways of declaring constants. You can either put constant, int, which is integer, and we're going to declare the blue LED. So we're going to be LU, blue LED, and we're going to make that equal to 13. And if we want to put a semicolon after that, that always ends your line. If you don't put a semicolon after your line of code, the computer is going to think that you're continuing writing another line of, or continue writing the same line of code, and it'll continue reading. So you want to put a semicolon so that the computer knows that you've stopped that line of code and you're going to go on to the next line of code. And again, if you want to comment this section out, you want to put declare blue LED pin. And I spelled declare wrong. Okay. There we go. And you want to do that to all your other pins. Now, if you spell it correctly, the color is going to change on the commands. So we're going to make constant green LED number 12, semicolon, constant integer. The next one is yellow. Keep the same convention here. Yellow LED equals 11, semicolon, constant int red LED equals 10. The spaces don't matter that much, but it's good to put spaces in. Makes it easier to read. Again, if you're very important to document your lines. Reason being is if you write your program and then say 3 months later you want to write your program again or modify your program, if you don't remember what you did, you'll have to start over again. So these are basically reminders to yourself on what you did for the program. Also, if you run into trouble and you need some help, best to document the program so that someone reading your program can have a better idea what you're getting at when you were working on your program. Okay, so we've declared all our constants. In the void setup, again, we're going to declare our pins. And pin mode is lowercase p, but uppercase M-O-D-E. Case turns orange, it tells you that it recognized it. So pin mode, we are going to declare our blue LED as an output. And we do the same thing with our all our other pins. Now, as far as declaration goes, it doesn't matter what order you do it, but I'm just going to follow the same order that we had as far as declaring the variables. Now, when I say declaring variables, these are variables here: blue LED, green LED, and these are what's up here. Now, if you didn't want to put your constants up here, or these are actually variables. If you don't want to put variables up, you can actually put pin mode, put number 13 there. Pin mode for green, you would put number 12 there. But it's better to use your variables at the top. That way, if you wanted to change something, say you wanted to change something on the board, all you do is change the numbers on here, and then everything else changes it below. So best to use variables when you're writing your programs. And where we're at, yellow LED. Yellow LED as output. And last one is the red. And again, once it turns blue on the output, you can tell that you typed it correctly. Again, here we're going to say declaring pin mode for keep doing that. Or that yellow. And I keep doing that. Oh well, have it. Okay. And this is a comment here, so I actually could delete that if you wanted to. How void setup is, yeah, it's a void setup, close, open and close brackets, and the curly brackets enclose all of the pin setups. Void loop is where you're going to put your constant programs. So say we wanted to blink all the LEDs, we're going to turn them all on, we're going to turn them all off, or we can turn them all on and turn them all off at various times. So let's do one at a time. So let's do the blue one first. So to turn on an LED, we're going to do a digital write. And we're going to do blue LED. And to turn an LED on, we have to, it's either high or low. So we're going to turn it on high. Now that has turned on the LED. So at this point, if you run this program, it'll turn the blue LED off, or it'll turn it on because it's high. Now what we want to do is do a delay. And what the delay does, it just waits, it's just a momentary wait in the program. So let's put 1,000 milliseconds in here. So that's 1 second. So at this point, the program is turning the blue LED on, and it's waiting a second. So let's turn it off now. And we'll do a digital write again. Go to the blue one again. And this time we're going to make it low. Now the state of being low is off. So on our pins, when we send signals to the pin itself, it's going to be high or low. A high signal is 5 volts, a low signal is 0. So with this statement, we're actually turning the blue LED off. And we're going to delay again. And again, what that does is just waits. Close and bracket. Now we're going to do the same thing to the green and blue and yellow red LEDs. So let's give us some space here. Let's do digital write, and we'll do the green one. We'll turn the green one off and turn the green one off as well. High. I'm going to delay at 1,000 milliseconds again. I need to pause the video because I'm typing too fast, or actually I'm typing kind of slow. But if you're not keeping up, you can certainly pause the video and then continue on. What I'm going to do is I'm going to copy the blue LED, the green LED, yellow, and red, and all the same, and we're going to make them all flash for a second. We're going to turn them off. So let's see, we're in delay here again. Okay, so that statement, that set of 4 statements, turns a green LED on for a second, turns the green LED off after a second. So next is the yellow. Now you may be tempted to copy and paste because we're typing exactly the same thing over and over again. But best to type it all out first time around just so you get the idea of what's going on, especially if you copy and paste, and especially if you're copying and pasting a long list of lines. I spelled something wrong here. You'll be copying and pasting your mistake over and over again. And missed the yellow LED part. LED there. There we go. Turn that low. So we're turning the yellow LED off. And we're going to delay a second. Next, the last is the red. And digital right, and I had my cap locks on. Here we go. And red LED. Turn it on. Put it on high, and that turns it on. Delay, again 1 second. And I'm going to put the red LED on low, which turns it off. And I'm going to delay again 1 second. Okay. So again, at the top here, now you can also document up here if you wanted to. I'm going to put another space to tell what this program does. Basic LED. Control. Flashing LEDs, something like that. And also in your when you save it, you can save it as a sketch. These are called sketches. When you're writing a program in Arduino, they're called sketches. Different terminology, but in essence, you're writing a program. So again, you're declaring your variables at the very top. In the void setup, you're declaring your pins so that the computer knows, or the Arduino knows what each pin is going to do. So these pins are all output pins, so we're sending a signal out as opposed to receiving a signal in. And then what we're going to do is turn the blue LED on for a second. I'm going to turn the blue LED off for a second. We're going to turn the green one on for a second. I'm going to turn the green one off. Wait a second. I'm going to turn the yellow LED on. We're going to wait a second. We're going to turn the yellow LED off. Wait a second. We're going to turn the red LED on. Wait a second. And we're going to turn red LED off. And wait a second. And after the loop, what the loop does, it'll go back to the beginning and start over with a blue again. So that is what our expectation is. So let's check the program. So on the top here, the very first icon is to verify. So if you want to click that, it'll verify. Actually, wants to save the program. Yeah, we'll just save it here. That's fine. And something wrong. A stray slash. Oh, had the wrong slashes here. So it's backslash. Okay. Let's verify again. And what verification does, it compiles the program. What compiling means is it takes these lines of code and changes it into machine code that the Arduino can understand. The computers only understand machine code, understand zeros and ones. Now we're writing in English, obviously, and in C code or modified C code. So again, what the verify does, it compiles the program so that the Arduino can understand it. So it's done compiling and there's no errors, everything is green, so we're good. So what we want to do is upload the program. Now if you want to go to the kit, you'll notice here the little transmitting. So these two LEDs are flashing, indicating a transmit. And you want to check our program. So the blue flashes for a second, green for a second, yellow for a second, red for a second. So we are successful in programming the Arduino to flash LEDs 1 second at a time. Now, a couple things you can do. Once you've done one at a time, you can flash them all at the same time if you wanted to by moving your digital rights around. Again, each line is telling the Arduino to turn it on or turn it off. You can actually move this one up here, and it'll turn both the blue and the red on, blue and the green on at the same time, delay, and so on and so forth. So, in fact, let's try that. I'm going to do a copy and paste here. So I'm going to copy the green high, and I'm going to put it right here. So we're going to turn both green LEDs on. I'm going to copy this one, and we're going to turn both green and blue LED on at the same time, and we're going to turn blue and green LED off at the same time, and then it'll continue on with the greens. So let's try that, see what that looks like. And take a look at your LED. So it's flashing green, yellow, red, both blue and green, green itself. So what we did was we changed that first line, and that allowed us to flash both green and the blue LED at the same time for a second and then turn off. So hopefully you understand how that delay works and how the turning high and low works. Again, high is turning on, low is turning off. And you want to experiment with that. You want to experiment with turning multiples on at a time. You can also change your delay time to see how fast or how long that it delays is. So a delay can, if you have a delay after it turns on, that just says you're going to leave the LED on for 1 second, we're going to leave it on for 2 seconds, 5 seconds, so on and so forth. If you want to make it shorter, you're going to have it flash really quickly and then have it off for a multiple number of seconds or milliseconds. This is basic control of an LED. I mean, it's almost like a traffic, well, basically it is a traffic light. So if you have the red, the yellow, and the green, you can actually duplicate a traffic light. But again, you want to change the program, see how the changes that you put in affect the program itself. And that's about it for our demo on basic LEDs. Come back for our next video for advanced LEDs, and we'll show you how to do a little bit more as far as control on the LEDs. Thanks for watching, and come back again.